Today, let's explore the VentMaster ventilation device program. Opening the VentMaster program, you'll see a window like the one I'm viewing on my screen. In the smaller window's left side, we can create a new client or enter a project address. For this purpose, I've already created a folder named Training. Clicking New Project allows us to create a ventilation chamber prototype. We need to name it. In this case, I call it AHU1, and also select and specify what type of device it will be. Possible ventilation device types include extraction chamber, air supply chamber, ventilation device with heat recovery, ventilation device with separate stream heat exchanger, or compact amber air CXV, CXH, or RH products. In this case, we'll explore a device with heat recovery. We must choose the installation location for the ventilation device. Why is this necessary? Based on the set location, the program will calculate the Eurovent Summer Energy Efficiency class and indicate it on your technical data sheet. After saving, we can open our system suggested by the program. The program offers us a standard layout of ventilation device components with which we can work. To select a ventilation device, we first need a request formulated by our client or designer. What request I choose for the ventilation device, you now see on your screen. Before starting to select a ventilation device, we must perform a very important step. On the left side of the window, clicking Extra, Connection Settings, and Login allows us to log in with our details. We must enter both a username and password. Salda will provide your login credentials. Once logged into the program, we will not only be able to select the device, but also see its gross price and create a unique offer number with which we can order the device from Salda in the future. So to start selecting the ventilation device, it's crucial first to enter the air parameters, the outdoor air temperature, and the indoor room extracted air temperature. In this case, during winter, our technical task says we have negative 23 degrees Celsius and 83% relative humidity. During summer, we have 26 degrees Celsius and 55% relative humidity. For both summer and winter, we have the same extracted room air temperature and humidity, which is 21 degrees Celsius and 55% relative humidity. The next and most crucial parameter is the air volume, expressed in cubic meters per hour in the supplied airstream. We have 8,000 cubic meters per hour of air, and in the extracted airstream, we have 7,500 cubic meters per hour. External static resistance in the supply air duct is 300 pascals. And on the extraction side, we have 350 pascals. After entering the air parameters, we can proceed to component configuration. We see a toolbar where hovering over any component provides a brief explanation of what that component is. In this case, the technical task tells us we need a rotary heat exchanger. Finding the rotary heat exchanger, click once with the left mouse button, and we can place it into the green zone. Clicking again on the green zone with the left mouse button to insert the required component, in this case, a rotary heat exchanger. We can configure it immediately. Our technical task states that we need an efficiency of over 80 at balanced flows. Entering 80 here, the program will select a heat exchanger that meets this requirement. The next step we need to perform is to select an electric heater. In this case, the program offered us a water heater, which does not suit us. Hovering over the component and clicking once with the right mouse button, we can remove the section. Again, after removing this section, we return to the component bar, find the electric heater, press the left mouse button once and insert the required component in the supply airstream after the fan. Another parameter we need to consider is the supply air temperature in winter. In this case, we have 22 degrees Celsius, and for the electric heater during winter, we need 21 degrees Celsius instead of 22. We enter 21. So far, it seems we meet all the requirements set in the technical task. To be sure, we need to calculate the ventilation device. On the left side, we click Calculate on the calculator icon. The system suggested us an optimal ventilation device according to our technical task. We can perform a quick check. So hovering over the electric heater, we see its main parameters: calculated electric power, nominal electric heater capacity. The same we can do with the rotary heat exchanger component. We see that the efficiency at balanced flows is 80.9, which meets the condition to have an efficiency higher than 80. Thus, having selected the ventilation device, we see its gross price on the left side without a discount and the blue lit offer request text, which upon clicking, we can obtain a unique offer number with which we can order this device or submit a request to SALDA. This is how a basic ventilation device is selected according to your technical task.